Well, everyone, boring lab. Oh my gosh, how could it possibly be? Get it? Boring. Okay, that's just that's going too far. But you could do boring like Niels Bohr. Remember we talked about Niels Bohr a little bit earlier. Well, maybe Bohr would probably like a good Bohr joke, as long as it's not boring like the giraffe kind of boring. Anyway, what we want to get to is the most boring lab of the year. Because it's so boring, we'll also make it super exciting. We'll do heavy metal day today, right? So we'll kind of try to balance out the boringness of the first lab with actually doing some heavy metal stuff and everything. Because what we want to do is talk about, well, different types of metal and what's going on with some of these metals that are happening. So first, there's a conductivity lab that's connected to this video where we're conducting a lab basically comparing the conductivity of a piece of wood, piece of glass, piece of metal, and piece of insulation right there. Right, so you can check on that. Let's see here. Hopefully you made your hypothesis, right? Then what we're going to be doing is checking the mass before in the video, right? We're going to be checking then the mass of afterwards for it, and we'll see which one was the most conductive. Okay, while normally in class, Noel, we're waiting for the most boring lab of the year to go on because it would just be so terrible to sit there and just watch the ice melt for like a half hour straight. Well, we go over some properties of metal, right? So that's why it's heavy metal day here and everything. So first, just what is a metal, right? Well, it's simply elements that have metallic properties, right? And so that's what we're going to go over today are, okay, what are some of the most important metallic properties that metals could possibly have? Right, so for example, you can pick any element that you want that's metal. I picked titanium because it's super cool. For a non-example, you'd want to pick an element that's not a metal, right? So say carbon or neon or oxygen, something like that and everything. Okay, so the first conductivity or the first element, or sorry, the first property of metals could be conductivity, right? Since we're doing the conductivity lab, well, let's talk about something being conductive. Right? It just means that it transfers, well, first, heat obviously is the one that we think of most commonly, right? Something that transfers heat easily and everything. But electricity is up there on the list too, right? If something's conducting electricity, well, sure, that makes it conductive, right? Sound is also another good one, right? How is sound being conducted? For example, sound does conduct through the air, right? You can hear a loud noise from, say, far away and everything. But it conducts even better in the water, right? If you're underwater, let's say in a pool on one end, and a friend of yours is on the pool on the other end, try going both of you underwater and screaming, and the other person can actually hear it. It actually transfers sound very well. So conductivity, it's more than just heat, it's more than just electricity, it could be sound too. And metals do a great job of conducting this, right? So metals are very, very conductive. So again, titanium is a great example of this, although copper is probably the most commonly used element for conductivity. That's what's in most wires and things like, if you have a wire or something like that, usually there's copper inside the middle there because it does such a good job of conducting it. Some elements are famous for not conducting things very well. So say like neon, for example. Neon, it can conduct electricity, right? That's what's inside of glass tubes for a neon sign and everything like that. Let's move on with the next one, malleable, right? Malleable is a property of metals that is very commonly used. Think of all the structures that we have in our world that are made out of metal, right? Think of cars, buses, trains, planes, all kinds of things, big bridges, buildings, right? They are still standing because of metal, right? Often metal is one of the main things helping to hold up these buildings. And that's all thanks to this property that you can form metal into a particular shape and it tends to stay in that shape, right? It resists that change. Coins, right? Good old-fashioned coins, right? Coins are a great example of this. You press a coin, right? Make it, into the shape that it is, and it will stay for a very, very long time. For in some cases, many, many decades, years, hundreds of years even. Something like a stuffed animal. Oh, wait, my stuffed animal right there. Yeah, that's not going to be a malleable thing, right? It's sure you can bend it, squish it, and things like that, but it doesn't hold that shape very well, right? When you squish it and let it go, it kind of like undoes its shape for us. Okay, let's kind of break things up as we're still waiting for the ice cubes to melt here. Right? A neutron walks into a restaurant. It asks the waiter, how much for a burger? And the waiter says, what to the neutron? Can't get it? How about this? For you, no charge. Get it? Neutron, no charge? Hopefully you get it. Ductile is our next one. All right, next up on the list is ductile. Right, ductile is this property of metals, and they can be stretched out into a long wire. Right, so basically what happens is you take let's say a big hunk of copper is the one that's we're most is most famous for this. You heat the copper up, you get it under just the right conditions, grab the both ends of it and stretch it out really slowly, kind of like Play-Doh. And under just the right conditions, we've learned you can basically just keep stretching it, stretching it, stretching it, stretching it, stretching it, stretching it into very, very long wires, right? And so that's what's known as being ductile, that you can pull and stretch the metal. It's like a form of malleability for it. Oh yeah, ductile, get it? Coming down towards the end here, we've got corrosion, right? Corrosion is just wearing away of metals because of a chemical property. By far, the most famous type of corrosion that you and I are familiar with is rust, right? Whenever you see rust, it's corrosion, right? It's just metal combining with oxygen, right? And when that happens, it turns into, well, basically rust or another type of material, right? So if you start out with some iron, it combines with the oxygen, it's forming iron oxide, it's forming a new type of material, right? That's a chemical change that's happened, right? And so when rust happens, is irreversible, right? If you take the poster child of rust, Mater here, or here's another example, maybe we have it right here, right? If you take, well, the PowerPoint stopped working, but there we go, right? If you take, corrosion to the extreme, let's say this poor car right here that happened, right? There's nothing you can do to get the metal back the way it used to be. Sure, you can sand it down and paste it and put some paste on it, smooth it all out, put new paint on it and everything. It might look good, but the original metal is not there anymore. Once it's rusted away, it's rusted away. You can't get that particular piece of metal back. You have to add more metal into it if you want to get it back. Then the next one here is metalloid, right? There is a particular little section of the periodic table called the metalloids. They're the elements that are between the metals over here and the nonmetals over there. The metalloids, they are elements that they kind of have properties of both, right? They're kind of metallic. Often they're very metallic looking if you just look at them and everything, but they don't have the same properties, right? Maybe they're not malleable, for example, right? You smack, a piece of one of these elements right over here with a hammer, and instead of it bending like a piece of metal would, right, it might crumble apart almost much more like a non-metal, right? Or how about silicone as the poster child of the metalloids, right? For years, they was considered to be a junk element. No one really knew what it did because, well, it conducted electricity sometimes. And, 100, 200 years ago, that was considered to be stupid. Why would you want something that only conducts electricity sometimes? But now we've learned to use that, and it's the basis for all of our electronics, is the fact that it can conduct electricity sometimes. So it's not really a metal. It's not really a non-metal. Those are the metalloids that go on the periodic table. And, if you like your phones, computers, video games, that's all thanks to the metalloids right there.